So this not KSP KW. So this question it's about. This one is about KW. तो वो वही कह रहे हैं कि write the expression for KW. So what is KW? KW is simply H+1 concentration times OH minus 1 concentration. That's what KW is. And use your expression for KW in the data booklet to calculate the pH of 0.15 mole per dm cube NaOH. So NaOH के case में what happens is it's a strong base. So it's going to produce Na+1 and it's going to produce OH minus 1 ions. So agar NaOH is 0.15 mole per dm cube, then that means OH ions is also going to be 0.15 mole per dm cube. Remember, strong acids, strong bases, that's easy because they fully ionize. And what you can do using this is you can find POH. POH would be the negative log of the concentration of OH ions, which in this case would be negative log of 0.15. Okay, so quickly tell me what the value for this is. Okay, what's log of 0.15? I'm getting 0.824. 0.824 for this thing. And since this is 0.824, pH would be 14 minus POH. Okay, pH plus POH is equal to 14. So that's going to be 14 minus 0.824. And then that gives me 13.16. Or we can say 13.2 because everything is getting rounded to 3 significant figures. That's the pH. Is clear? Is this clear? अच्छा फिर ये कि और कौन actually missing है? Similarly, suggest why this answer differs from the answers. The other question, next one. Next one is saying that the pH of 0.15 mole per dm cube solution of piperidine is 11.9. Okay, it's this thing. Suggest why the answer differs from answer in C2. So get a same concentration, but this one has a different pH. Why? Because it's a weak base, which means it ionizes partially. So it's not ionizing completely. That's why you're getting a weaker base. So you have a weak base ka question. And he's saying how would the basicity, how would you expect the basicity of piperidine to compare that of explain your reasoning? I mean that's a weaker base. In दोनों में फर्क क्या है वैसे? The only thing is, I think over here you just have to write that ionizes partially. So OH ion concentration would be lesser. And over here you're going to just state that it's a weaker base, okay? Not really sure कि इन दोनों में difference क्या answers में. It's suggests why the answer differs from it's obviously a weaker base, less ionization. Sorry. Then this one is an organic question, so we can just ignore that. This is a totally different question that's related to organic. Either organic वाली reason, and he's comparing it with ammonia and not with anyway. So we leave this part. Similar questions. ये तो किसी का आ गया था. I guess. You got this acid. He's saying suggest equations showing two dissociations And again, this one is a diprotic acid because if you look carefully, it's got two carboxylic acid groups. There's a carboxylic acid group and there's another carboxylic acid groups. So one of them will release an H+1, then the other one would release an H+1 as well. So उससे क्या है कि tartaric acid has two dissociation constants K1 for which pK values are 2.99 and 4.4. This is the first dissociation. That's easy. Lower value means whenever you have a lower pK value, that means you got a higher Ka value. That means more dissociation. Okay, so remember the first dissociation is going to be stronger. Okay, the first H+1 is going to be produced easily. Or pK higher ka matlab hai that you have a lower value of K. That means the second dissociation is going to be less. अच्छा तो इसी को discuss this further that discussing this further that two dissociation. So what is the formula of this thing? It's I think it's side pe left side there's COH, then in the middle there's CH within OH branch, then there's another CH within OH branch, and then there's another COOH. So this is the formula of the thing. So I suggest equations to show the two dissociate. So starting with this one COH or beach mein there's CHOH. First time lagega COH. The first dissociation is the first H+1 is going to be lost from either end. So you have CHOH, then another CHOH, and then there is COO -1 and an H+1 is lost. Second association is that once the first one is lost, इसको बल्कि twice कर लेते हैं. अच्छा, once the first one has lost, the second H+1 is also lost. So another H+1 gets produced. Well, left side says CO -1 and there's CHOH in the middle twice, 2 times. And then there's COO -1 as well. So that's your 2 acid dissociations. All acids, they would dissociate in this way. Okay, they're going to produce H+1 and they will produce some leftover ion. So I guess that's about it for Ka. I mean the first part of K. Okay, let's do the remaining part. Okay, what else do we have in this chapter? So the other stuff that we have is related to K once more. Okay, hopefully K is clear. Acid, it ionizes, produces 2 ions. It's in equilibrium. There's an equilibrium constant, which is Ka or Kc. It's product concentration over reactant concentration. These 2 ions will have exactly the same concentration. So this same formula becomes H+1 squared. Achha, ye sara clear hai na saro ko? Is this clear? Siddha, Rizwan, Anna, Alicia, is this all clear? Okay, aage move kar le.
Yes.
So now, chalo. Now the next part is buffer solution. It's the same as a buffer solutions. Kind of the same thing. Thoda sa complicated hoga. Okay, but it's kind of almost the same thing. So first thing, what is a buffer? As remember, I told you already that pH is kind of something that's very important because the pH should not change. Okay, your reactions, they depend on the pH. They depend on the concentration or the balance of H+1 and OH ions. Like if the solution is neutral, that means H+1. So if the solution is neutral, then if the solution is neutral, that means the concentration of H+1 and the concentration of OH ions is exactly the same. 1 times 10 power -7 and 1 times 10 power -7. If the solution is acidic, then the H+1 will be having a higher concentration compared to your OH -1 concentration. Or तीसरा ये कि if the H+1 is if it's a basic solution, then H+1 would be lesser compared to your OH ion concentration. But anyways, whatever that is, the pH should not change. Reactions are dependent on the pH, and every reaction prefers a certain type of solution. They either prefer acidic, strongly acidic, weakly acidic, or they prefer basic. Those may be strongly basic, weakly basic, or they would either prefer neutral. They're very specific or touchy about the pH. तो pH जो है वो जरा सा भी change नहीं होना चाहिए. Otherwise the reactions will get affected. So if you have your stomach, it should remain always acidic. So the pH has to be maintained. So pH has to be maintained. यानी soil के अंदर अगर आप plants लगा रहे हो ना, the pH should not change. It should be the preferred pH of the plants. Has to be maintained and kept constant. Otherwise, the reactions are affected. So otherwise, your reactions are going to get affected. So how do you keep the pH constant? That's known as a buffer solution. Buffer solutions, they resist a change in pH. Achha, most of the natural systems that you see around you, they're buffer solutions. यानी आपका जो soil है ना, it's going to resist a change in pH. Your blood will resist a change in pH. Your stomach will resist a change in pH. They're by default natural buffers. The buffer solution is a better definition. They're going to ask you about the definition. So it's a it's a solution that resists a change in pH. So it's a solution that resists a change in pH when small amounts of acid or alkali is added.
Sir?
Oh.
Sir, ये जो buffer solution है जितने भी equilibria इसके like 2022 to 2024 syllabus और इसके previous जो है उनके बीच में कोई difference है वैसे?
नहीं.
Okay.
अच्छा, when a small amount of acid or alkali is added, ठीक है? एक बार वैसे check भी कर लेते हैं latest syllabus. This one is 2022-24. अच्छा, एक तो मई जून वाला एग्जाम हो चुका है. इक्विलिब्रिया, जस्ट सेकंड. अच्छा, दिस इज ये एस है. Understand reversible reaction, Kc and Kp. This is AS. 1 second. And A2 will be. Achha, why is it? अच्छा, अब सही है. ये हो गया acids and bases, ठीक है? तो वही strong acids, weak way to define a buffer solution. We add this part, ठीक है? ये वाला part, we did this part, pK, etc. I mean, Kb is not in your course. That was previously not in your course as well. So make sure Kb and I mean this thing Kb is not in your course. Kb basis के लिए होता है. So we don't study about weak bases. Do you remember that? We only study weak acids in this syllabus. So just keep that in mind. Okay, weak base का pH कैसा calculate होता है? I mean, although it's exactly the same as Ka, but you're not supposed to know that. I said, so we are at this point. Define a buffer solution, explain how a buffer solution can be made, explain how buffer solutions control pH, use chemical equations, and describe and may calculate the pH of buffer solutions given appropriate data. Okay, so balki blood ka bhi role of HCO3-1, you have to do an example as well. So starting with the definition, we already done with the definition that it's a change in pH when a small amount of acid or alkali is added. ठीक है, so small amount, क्योंकि अगर large amount डालोगे ना तो it will eventually change the pH. Like your stomach, ठीक है, you can eat anything and the pH of the stomach will not change. That's the first thing. How is a buffer solution made? Okay, what a buffer solution will do is that it will neutralize any alkali or acid added. Okay, so that's what a buffer solution does. So this is what it typically does is that a buffer solution, uski jo working hai, it neutralizes the small amount of acids or alkalis added. That's a small amount of acid or alkali added. So how do you make a buffer solution? It's a solution that's made up of a weak acid. You need two things for this. You need a weak acid plus the conjugate base of the same weak acid. Conjugate पूरा लिख लेते हैं. Conjugate base of the weak acid. So here's what's going to happen. Two things required. So let's say I've got ethanoic acid. So ethanoic acid is CH3COOH. That's the weak acid. I'm trying to make a buffer. Now ethanoic acid will ionize weakly and it will produce two ions. Ethanoate ions, CH3COO minus 1. Or Sathina, it's going to produce H plus 1 ions. Now this over here is your weak acid. Okay, so you need a weak acid. Plus at the same time, you would also need so that's the weak acid. And remember, a weak acid will produce a conjugate base. So you need two things. You need ethanoic acid, plus at the same time, you also need its conjugate base. You need both of them in the same solution, and that will form a buffer. Okay, so so any other equation, any other weak acid, let's say I talk about let's say if I have ammonium ions, that's a weak acid. Okay, so ammonium ions, and they're going to ionize weakly, and they will produce two things. They'll produce ammonia, and they'll produce H plus 1 ions. So one of them is a weak acid. And this over here is the conjugate base of the weak acid. Okay, so I would need both things. Yeah, in simple terms, what I can state is that if I have HA as the weak acid, it will ionize and it will produce two things. It's going to produce A minus 1 and it's going to produce H plus 1. So to form the buffer, I would need both things. I would need the weak acid plus its conjugate base. So the acid would come in all sorts of different shapes and sizes, but the general dissociation would be kind of exactly the same. So anyways, what do we do with this when you have a weak acid and you've got the conjugate base as well? So remember, he was asking for the equations. So I've got a beaker over here. And let's imagine that the beaker is full of So let's imagine this one. Okay, the beaker has a lot of ethanoic acid in it. So there is CH3. Let's say there are 3 molecules of ethanoic acid. And the beaker also has the conjugate base as well. So let's say there is CH3, COO minus 1, another CH3, C00-1. So ये काफी है. So this over here is your typical buffer. It's going to have both ions. It's going to have weak acid plus its conjugate base as well. So hopefully the idea clear है कि what's a conjugate base. A weak acid will always ionize and it will produce a conjugate base. ठीक है, ये idea clear है? यहाँ तक clear है? कि buffer में कौन सी दो चीजें चाहिए? ठीक है?
सर
हाँ जी.
सर और एक एसिड ज्यादा होगा ना एज कंपेयर टू लाइक, क्योंकि वो पहले से ही एसिड है, H प्लस में ज्यादा होगा.
किस पे ज्यादा होगा?
लाइक वीक एसिड जो एथेनोइक एसिड आप बता रहे, इसमें H प्लस ज्यादा होगा ना एज कंपेयर टू बेस.
नहीं, मैंने अभी सिर्फ ये कहा कि बफर बनाने के लिए ना you need this and you need this. You need a mixture of two things.
ओके सर.
अभी मैंने नहीं डिस्कस किया कौन सा ज्यादा होगा कौन सा कम होगा. मैंने बस कहा कि if you want to make a buffer ने क्या करना है? It's going to resist a change in pH. It will neutralize जो भी acid आप डालोगे, it will resist a change in pH. ठीक है? It will neutralize the acid. If you try to add alkali to it, it will neutralize it. ठीक है? तो वो कर लेते हैं कि let's say I've got this buffer. ठीक है? If I try to add, now look at coming to equations, if I try to add H plus 1, like if I try to make the solution acidic and I start adding H plus 1 ions, but how do I add H plus 1 ions? I must be adding an acid. Like if I start adding HCl or H2SO4 or something, and there's more and more H plus 1 ions coming in, right? So all of a sudden, आपका जो solution है उसमें H plus 1 ions will start going up, right? Because you're adding too many H plus 1 ions, right? So who's going to attract those H plus 1 ions? The negative ions over here, the conjugate base. It will immediately grab hold of them and it will neutralize them. ये जो H plus 1 जाएगा ना, ये इस negative ion के पास जाके attract होगा. So this H plus 1 will go and it will be absorbed by the ethanoate ion. So this is the reaction that's going to happen. That if a small amount of H plus 1 is added, and if somebody tries to make this solution acidic, right? So the conjugate base will neutralize the H plus 1 ions. So the ethanoate ions that you've added will accept those H plus 1 ions and will form ethanoic acid. And it will form ethanoic acid back again. And all your ethanoate, your extra H plus 1 that you've added, they will eventually get neutralized. So ये सारे जो H plus 1 है ना, they're getting neutralized, they're getting absorbed by. अच्छा, लेकिन आप ज्यादा नहीं डाल सकते क्योंकि there's going to be a limited amount of ethanoate ions. ठीक है? If you add too many H plus 1 ions, the ethanoate ions will all get used up. But at the end of the day, your H plus 1, the tiny amount of H plus 1 that you've added, they would eventually get neutralized. Okay? So the idea clear? That's the equation. Okay, if H plus 1 is added. Is this clear?
Yes, sir.
As similarly, if you add OH ions now to the same solution and you try to make the solution basic, so OH ions add karoge, so all of a sudden your solution will become more basic. It's going to have a lot of OH ions in it. So now, who's going to neutralize those OH ions? ये जो weak acid है ना, it's going to release its H plus 1 ions, and those H plus 1 ions will go and react with OH ions, and they would neutralize it. ठीक है? So if तो अगला part है कि if OH ions are added, a small amount, या आपके blood वगैरह सब में ही चल रहा होता है. ठीक है? If OH ions is added, so what happens in this case is that the weak acid will neutralize the extra OH ions. So weak acid will neutralize OH ions, and this is how they're going to do it. कि जो ethanoic acid होगा ना, because it's a weak acid, its purpose is that it releases H plus 1 ions. So when it sees OH minus 1, that's a negative ion. So OH plus 1 or be readily will get neutralized, will get released. And remember, a weak acid will behave as a strong acid if there's OH ions. Basic conditions when it's going to ionize more. There's a reason for that. Okay, it's a negative ion, right? So the OH plus 1 खुद ही automatically attract होगा because it's a positive ion. So it will get attracted to the negative ion. So there's going to be more ionization in this case. And it will become CH3CO minus 1. Or wo jo OH ion hai, that will become water. So your OH ions will automatically get neutralized. So you've got your two equations now. Okay? So remember this idea that in the solution, you need a weak acid. Why? If somebody adds OH ions, the weak acid will go and start neutralizing the OH ions. Vice versa, you need the conjugate base as well. If somebody adds H plus 1, so that H plus 1 will go and will get attracted to the ethanoate ion, the conjugate base, and the conjugate base will accept it and it will neutralize it as well. So is this idea clear that how neutralization is happening? Is this clear?
Yes, sir.
ठीक है, बाकी सारों को clear? Raid, is this clear? Nasib, Shan. So now the thing is that you can also link it up with equilibrium, that it's basic equilibrium that's happening. Okay, if you add too much H plus 1 ions, the equilibrium will shift backwards, right? Like if you add H plus 1, the H plus 1 will react with the ethanoate ions and it will move backwards. And if you decrease the quantity of H plus 1 ions, the equilibrium automatically forward shift hoga. It will start producing more H plus 1 ions. Okay? So you can link this up with equilibrium. It's basic equilibrium that's happening, basic Lee-Shatler principle that's happening or taking place. The equilibrium forward shift ho jata hai, equilibrium will shift backwards as well. So taking this equation forward, इसी को उठा के ना copy कर लेते हैं, क्योंकि it's the same reaction, right? Achha, but you should know how to make these equations. Achha, so basically it's this equilibrium that is shifting forwards and the same equilibrium that is shifting backwards. Achha, but there is one problem over here, and that is, अब उस पे आ जाते हैं. Okay, conceptually it's pretty easy that you add ethanoic acid, you also add the conjugate base. Now remember, this is a weak acid. So the conjugate base that will be produced from the weak acid will be very small. ये जो ions होंगे ना, ये बहुत कम होंगे. It's not going to be a lot because remember, ethanoic acid does not ionize. So the solution would actually kind of look like this: that it's going to have a lot of ethanoic acid. So the quantity of ethanoic acid would be a lot. अच्छा ये ज़्यादा होंगे. You remember, ethanoic acid is a weak acid, so it's not going to ionize a lot. So here's another ethanoic acid. Here's another one. Achha, here's another ethanoic acid. And since the ionization is a weak acid, so very few ethanoate ions would actually be produced. So इनकी quantity जो होगी ना, ये जो इनका color change कर लेते हैं, green कर लेते हैं. अच्छा, इनकी जो quantity होगी, that would be very small. So that creates a disbalance because remember, हमें तो दोनों चाहिए ना. We need ethanoate ions and we also need ethanoic acid as well. But is this point clear? Why this ion will be less in quantity? Because it's a weak acid. It does not ionize. It does not produce a lot of ethanoate ions. Is this point clear?
Sir, थोड़ा सा connection का issue था, आप इसे explain कर सकते हैं?
मैं खाली ये कह रहा था कि जब आपके पास weak acid होता है ना, तो it doesn't really ionize a lot because it is a weak acid, right? So again, if I add 10 molecules, then hardly one of the ethanoic acid will ionize and it will produce ethanoate ions. So I'm saying, okay, naturally in a solution, the quantity of the conjugate base will be very small compared to the quantity of weak acid. Is that clear?
Yes, sir.
क्योंकि वो ionize नहीं करेगा, ठीक है? तो हमें तो दोनों चाहिए ना. We need ethanoate ions. ठीक है? We need ethanoate ions, right? And at the same time, So we need both things, right? We need the ethanoids. But at the same time, so we need ethanoids, but at the same time, we also need ethanoic acid. So how do we increase the quantity of ethanoids? वो हम increase करते हैं और पहले मैं इधर note भी लिख लेता हूँ कि weak acid doesn't ionize much. So how do we increase the quantity of ethanoids? You increase its quantity by adding a salt. ठीक है, तो इसकी quantity जो है, that quantity is so very few ethanoids in the first place. So add a salt of the weak acid. For example, if you have sodium ethanoid, add that. So if you add a salt of the weak acid, then the quantity would automatically increase, and there's going to be more and more ethanoids. Because वो जो weak salt है ना, that will dissolve and mix in water, and that will increase the quantity of ethanoids in the solution.
So,
हाँ जी.
सर आप कह रहे हैं कि हम लोग सॉल्ट डालने से मतलब इथेनॉइड की क्वांटिटी बढ़ जाएगी, तो अगर हम लोग फर्दर इथेनॉइक एसिड को ऐड करते जाए तो इससे क्या इथेनॉइड आयंस और ज्यादा नहीं हो सकते?
नहीं, लेकिन वो है ही weak acid ना, तो it doesn't really ionize a lot to begin with.
ओके सर.
वो किसी भी K वैल्यू देखो ना, it's 10 power minus 12, 10 power minus 13, so that means it's very weak ionization. कि अगर आप, if you have 10,000 ethanoic acid, maybe one of them ionizes. तो इससे तो एक्सपेक्ट करना कि ये प्रोड्यूस करेगा एथेनोइड, that's it's not going to produce a lot of ethanoids to start with. So most of the ethanoids will be coming from the salt. You're going to mix a salt. तो आपका जो बफर बनता है ना, conceptually it's a weak acid with a conjugate base, but technically it's a weak acid with its sodium salt or any soluble salt. तो ये जो ion है ना, this one, so it's basically weak acid, and the conjugate base is usually a soluble salt of the weak acid. It has to be a soluble salt, remember that as well. तो आइडिया क्लियर है बफर का कि ethanoic acid plus conjugate base, ठीक है, it forms a buffer. Add OH or add H+1, they both get neutralized. कि अगर H+1 डालोगे, the conjugate base will start grabbing those H+1 and form ethanoic acid. It will neutralize the H+1 ions. So vice versa, if you add OH ions, the weak acid will ionize and release an H+1, and that will neutralize. It will form water, and the OH ions will get neutralized. In both cases, the H+1 added and the OH ions added, they have been somehow neutralized, by adding ये इन दोनों के mixture से. So is this all clear so far? ये clear है सारों को? Okay, what's a buffer?
Yes, sir.
And so finally, the last thing is, this over here is the same exact expression. Weak acid ionizes, and it's the same exact equilibrium. There's going to be an equilibrium that will be formed. And remember, this is the same equilibrium. There's no difference. वो जो पहला equilibrium था ethanoic acid वाला, कहाँ है? Like if you look at the, like it's the exact same equilibrium. Okay, weak acid ionizes, produces a conjugate base, and produces H+1 ions, and that's the dissociation constant. So remember, even if it's a buffer, तो मैंने क्या कहा था, equilibrium constants they only change with temperature, they don't change if you change the concentration, right? So it's exactly the same ionization, it's the exact same कि वो HX है, ionizes, produces A-1 and H+1, it's the same exact equilibrium that's established. So you'll have the same exact K expression with one difference. तो आपका K का जो expression होगा that would be exactly the same, but with one minor difference. तो K का expression इस केस में क्या आ रहा है? It's coming out to be CH3CO -1 concentration. अच्छा, into H+1 concentration divided by CH3COH concentration. ठीक है, so it's exactly the same expression, but with one difference, and that difference is, और ये difference याद रखना, ठीक है? Remember, it's the same expression, same K value, everything is the same. K only changes with temperature. It's the same exact equilibrium. One difference that is कि इन दोनों ions की concentration जो है ना, it's no longer the same. Why? Because ये वाला जो ion है ना, you've added more of it, you've added extra of it. वो कहाँ से add किया था? You added a salt of the weak acid, right? तो आपका ये वाला जो ion है ना, वो extra add हुआ है, and it's coming from the salt. ठीक है, so you've added more of it. तो इन दोनों ions की concentration is no longer the same, and your expression actually kind of looks like this. It's the conjugate base concentration, which is basically kind of the salt concentration, into H+1 concentration and divided by the acid concentration. So this ion over here is coming from the salt. ये आपने extra बीच में add किया, ठीक है? So most of it is coming from the salt, and that's your new expression for K, which is kind of the same expression except for कि वही product over reactants है, except for one difference, and that is कि ये वाला ion जो है, more of it has been added from the salt. Very few ions were actually coming from the dissociation of ethanoic acid. Most of the ions that you actually added into the solution that were ethanoate ions, they actually came from the salt. So the idea clear? Is this clear? Risha, clear?
Yes, sir.
Sita, is this clear? Bakiyon clear? So that's going to be the expression for a buffer. So just remember, एक छोटा सा difference है, and that is, छोटा सा difference क्या है? कि if you have a weak acid only, so these two ions will have exactly the same concentration. So you can change this expression ऊपर वाला to H+1 squared, right? That's what you can do for in a weak acid. Both ions will have exactly the same concentration, but in a buffer, वो जो conjugate base है ना, वो आप extra डालते हो, ठीक है? How do you increase it? By adding a salt of the weak acid, like sodium ethanoate, ठीक है? तो ज्यादातर ions जो हैं वो वहां से आते हैं, and that kind of makes so in that case these two ions are no longer exactly the same. ये extra add किया आपने, ठीक है? तो expression is exactly the same, except you can't equate them now. The conjugate base concentration over acid concentration into H+1, K value would be exactly the same. ठीक है, it's the same. हाँ जी
सर, जो पहले वाले इक्वेशन हम लोग लिखते थे कि H+1 और कंसंट्रेशन का स्क्वायर लेते तो यहाँ पे नहीं हो सकता ना?
हाँ, क्योंकि ये दोनों exactly same नहीं है ना.
यस,
क्योंकि ये तो बाहर से एक्स्ट्रा डाल दिया ना बीच में, क्योंकि वो वीक एसिड जो था वो तो आयनाइज कर ही नहीं रहा था ना, वो तो बहुत कम कर रहा था. तो ये वाला आयन हमने एक्स्ट्रा सॉल्ट के थ्रू डाला था बाय एडिंग सोडियम एथोरेट, ठीक है?
यस.
So just remember, this is the third formula, and that's your buffer solution formula, which is नहीं इक्विलिब्रियम तो शिफ्ट होगा obviously, but remember K value जो है that remains constant. I mean Kc values, equilibrium constant values, they always remain constant. वो इक्विलिब्रियम शिफ्ट ही इसलिए होगा कि अगर ये ज्यादा हो जाएगा ना तो इक्विलिब्रियम ऑटोमेटिकली प्रोडक्ट ओवर रिएक्टेंस का जो रेशियो है ना दैट वुड ऑलवेज रिमेन कांस्टेंट. तो अगर आप ये बढ़ाने की कोशिश करोगे ना तो वो लेफ्ट राइट कहीं ना कहीं शिफ्ट होगा, ठीक है, लेकिन इट विल नॉट अफेक्ट द वैल्यू ऑफ के. सिर्फ टेम्परेचर चेंजेस द वैल्यू ऑफ के, और टेम्परेचर इंक्रीज करता है. वाटर का कांस्टेंट आयनाइज ज्यादा करेगा, ठीक है, और dissociation constant acid will ionize more as well if you have a higher temperature. तो वो ज्यादा आयंस बनेंगे तो इट्स गोइंग टू इंक्रीज. चलो ठीक है, इसके क्वेश्चंस रिमेंबर ये बस फॉर्मूला, ये आइडिया याद रखना कि वी डिड ऑल ऑफ इट. you should know कि how are the equations made. I mean they'll ask you for the equations, ठीक है, कि OH डाला तो what did it do, it got neutralized, ठीक है, H+1 डाला what happened, it also got neutralized. And they'll ask you for the K. इससे ना आप pH निकालोगे. we'll do that in the next class, ठीक है. चलिए ठीक है, कल पे बात करते हैं इस पे. Okay everyone. ठीक है, अल्लाह हाफिज.